So in the last lecture we saw that in free space Maxwell equation suggested that the electric field and magnetic field behave like a wave. Remember, in source free region. Okay, now on today's lecture we will discuss how electromagnetic wave equation transform under Galilean transformation. First of all, let us see what is Galilean transformation and what are the postulates under which this transformation law works. First postulate is the laws of motion remain invariant under this transformation. And the second and the most important postulate is the speed of there is no absolute speed limit in nature. The absolute simultaneity is possible. So we take two frames, one is S, another is S prime. The S prime coordinate system is moving with a constant velocity in the positive x direction. So the transformation law would look like x prime will be x minus vt, y prime will be y, z prime will be z, and t prime is t. Now the electromagnetic wave equation under Galilean transformation. So del square B equals to mu naught epsilon naught del 2 del t square B and del square E mu naught epsilon naught del 2 del t square E. I am expanding this wave equation in Cartesian coordinate. So it would look like this: Bx, By, Bz, and I am simply writing B vector, otherwise I have to write Bx, By, Bz corresponding the time derivatives. Remember one thing, B is a function of space and time both. It is not that it is a function of space only or time only. It is a function of both. Not only B, it is also true for E. So, now for simplicity, I am considering a 1D case. So, in 1D case, the wave equation would look like this: del x square bx equals to mu naught epsilon naught del t square bx. I am writing it as equation 1. So under Galilean transformation, let us see how the wave equation transform. So x prime is x minus vt and t prime is t. So the del x of bx, using chain rule, I am writing del x prime of bx del x prime del x plus del t prime of bx del t prime del x, and previously I am writing these four derivatives from here. It is very clear that del x of del x prime will be 1 and del x of del t will be minus v, del t prime of del t will be 1 and del t prime of del x will be 0, as t prime has no x dependence. Okay, again I am substituting this value here, we are getting del x of bx equals to del x prime of bx. I am taking another derivative, so it will be del x2 bx equals to del x prime to bx. We are writing this as equation 2. Now we are considering this part. First we are taking del t of bx equals to del t prime del t using chain rule. Again del x prime del t. Now del x prime del t is minus v from here, so we are substituting that, and del t prime del t is 1, so it will be just simply 1, and let f equals to del t of bx. So I'm doing it just for simplicity, it is not necessary. So f is minus v del x prime bx plus del t prime of bx. If we take another derivative, it will be del t of f minus v del x prime of f plus del t prime of f. I am substituting f is this, and I am substituting this f here and here. So finally we will get this. Now this is 3. I am substituting 2 and 3 into equation 1. So what we will get? We will get del del x prime square bx equals to mu naught epsilon naught v square del del x2 bx minus 2v del del x prime del t prime bx plus del del bx del t prime square. Oh, one thing you should remember that these two derivative commute. Del del x prime del t and del t prime of del x prime, they commute, they are same. Okay, so if we do some simple algebra, we will get this. I am writing this as 1 by c square. So finally this transform and it becomes like this. So clearly it is not an invariant under Galilean transformation. If it is invariant under Galilean transformation, it should have the same form just like this. Okay, so the form is changed. Remember one thing, Newton's laws are based on Galilean transformation. They do remain invariant under this transformation, but here we can see the wave equation or the electromagnetic wave equation are not invariant under Galilean transformation. So we hit another problem. First, on the first lecture we hit one problem, that the Lorentz force law giving us different sets of equation of motion in same under inertial frame transformation, and again we are saying under inertial transformation the wave equation, the electromagnetic wave equation is not invariant.